For this problem, we're going to find the local extrema of f on the given interval. So we're only going from pi over 6 to 5 pi over 6. But to find our local mins and maxes, we need to go ahead and find the critical values. So first, derivative of f of x. Here we're going to need the chain rule. We're going to do the derivative of the exponent part first. 2 times cotangent to the first of x. Then we have to multiply by the derivative of cotangent, which is negative cosecant squared. I'm going to put the negative out in front, cosecant squared of x, plus here we just have 2 times the derivative of cotangent, which again is negative cosecant squared. So I'm going to make this plus a minus 2 cosecant squared of x. We can go ahead and factor this, and we can take out a negative 2 cosecant squared. So we're left with a cotangent of x in this first term minus 1. Now remember, to find critical values, we need to find when is the derivative 0. Oops, first derivative, not the second. When's the derivative equal to 0? And we want to know when is the derivative not exist. We need to keep both of those in mind when we're finding critical values. So let's start off when it's 0. Here we can set each of these factors equal to 0. This one we can divide by negative 2. Cosecant squared is 0. Take the square root of both sides. So cosecant of x is 0. Remember, cosecant is reciprocal of sine. So if cosecant is 0, sine has to be the reciprocal of that. So sine of x would have to be 1 over 0. And we know that's not possible, so that doesn't give us any solutions. Now, let's take a look at the second one here. Here, add 1 to both sides. Cotangent of x equals 1. And remember, cotangent is the reciprocal of tangent, so if, oh, hold on a second, I just realized the mistake I made. Up here, this should be a plus 1 when we factor out the negative 2. So this ends up being cotangent of x equals negative 1. Probably caught me on that earlier than I did. So cotangent of x equals negative 1. That means tangent of x is also going to be negative 1. It's just the reciprocal, comes out to be the same thing. So on the unit circle, we're trying to figure out when do we have an angle that has a tangent that's equal to negative 1. So the sine and cosine are the same but opposites. So one's positive, one's negative, and that's going to happen in the second and the fourth quadrants at 3 pi over 4 and 7 pi over 4. Now, remember, we're on a strict interval this time. We don't have to put all of the possibilities. So in this case, the only answer that falls between pi over 6 and 5 pi over 6 would be 3 pi over 4. So that's our only one for this. Now, we found out when the derivative is 0, but don't forget we have to figure out, is there a time when the derivative does not exist? Because if there is, that's also a critical value. So if we look at each of these factors, negative 2 cosecant squared of x, well, remember cosecant's reciprocal of sine, so really this is like negative 2 over sine squared of x. So if this denominator was equal to 0, that would make it the derivative not exist. So we want to figure out what makes sine squared of x equal to 0. Well, take the square root of both sides. We get sine of x equals 0. So on the unit circle, our sine is equal to 0 at 0 and pi, but that doesn't fall in this interval, so this doesn't help us at all. But we do need to take that into account because it could possibly give us a critical value. Here, if we look at our other factor, cotangent of x plus 1, well, cotangent is cosine over sine. So again, if this denominator is equal to 0, that makes this derivative not exist. But we end up with the same problem that we had before. neither of the answers are going to fall within this interval. So in this interval, there are no points where the derivative does not exist. This is our only critical value. So we want to find out, is it a minimum, a maximum, or neither? Let's take a look at a number line. So the only number we're putting on here is 3 pi over 4. We know the derivative is 0 at that point. We need to plug in some values to the left and to the right and figure out if we're positive or negative. So to the left, I'm going to go ahead and put in pi over 4. So if we look at our derivative up here, we have cosecant squared of x. So cosecant of pi over 4, well, when we square that, it doesn't matter, that value is going to come out to be a positive number. So we have this negative 2 times a positive value. And right here, if we do cotangent of pi over 4, that's going to be 1 plus 1, so that's a positive value. That means we're going to get a negative over here. Our derivative is going to be negative, so the function is going to be decreasing. If we look to the right of pi over 4, let's take a look at, um, let's see, we're going to have to do 5 pi over 6 so that it falls in that interval. So 5 pi over 6, again, this is going to be negative 2. This is going to be positive because we're squaring something, so it's always going to come out to be positive. Cotangent of 5 pi over 6, so that's cosine over sine. Well, 5 pi over 6, our cosine is negative root 3 over 2. Sine is 1/2. So we're going to have negative root 3 over 2 over 1/2, which comes out to negative root 3 plus 1. That's going to make this a negative value. So if we have a negative times a positive times a negative, we're going to get a positive value. That tells us we have a local minimum at x equals 3 pi over 4. So that's our local minimum because it's decreasing and then changing to increasing at that value.